Okay, let's dive right into something that touches almost every aspect of our lives now. Artificial intelligence.
Hmm.
We see AI taking on tasks that used to be exclusively human, like, recognizing objects, making
Yeah.
complex calculations, and even
Uh,
controlling physical systems like cars or robots on a factory floor.
yeah, definitely.
But what happens when these tasks aren't just about boosting efficiency, but about absolute non-negotiable safety? When the stakes are literally life and death?
Hmm.
Do we just hand the keys over to the algorithms, or is there, well, a different path forward?
That's really the fundamental question this deep dive explores. And the path isn't about replacing humans entirely,
Okay.
but about how humans and AI can work together, side by side,
Mm-hmm.
especially in those environments where safety is absolutely paramount. Researchers are calling this collaborative intelligence.
Collaborative intelligence.
Oh,
Okay. It sounds like finding a way for both sides to bring their A game, so to speak.
yeah.
To really understand this, we've pulled together insights from several recent research papers and literature reviews. They really dig into what this human-AI partnership looks like in practice,
Uh-huh.
the significant hurdles it faces, and, well, how folks are actively working to make it safe and effective.
Exactly. Our mission here is to extract the most important findings from this body of research.
Right.
We want to understand the core idea behind collaborative intelligence, pinpoint the unique challenges that come up when you integrate humans and AI in these safety-critical systems,
Hmm.
and crucially, see the specific ways researchers are actually addressing these challenges.
Hmm.
We'll look at concrete examples, especially from automated driving,
Okay.
to see how AI assists humans, how humans, in turn, are essential for assisting AI, and why the human element remains absolutely non-negotiable for safety.
All right, let's unpack this idea of collaborative intelligence first. Beyond just automation, why is partnering with AI the key approach in these high-stakes settings?
Well, at its core, collaborative intelligence, or CI, it's about achieving a powerful synergy between humans and machines. It absolutely leverages the incredible advances we're seeing in AI and machine learning,
Sure.
but with a critical principle, particularly in safety-critical systems.
Hmm.
You don't replace the human.
Ah.
You integrate them to collaborate, using that partnership to mitigate the limitations inherent in both the human and the machine.
So it's less about automating the human out of the system and more about, like, building a partnership.
Precisely.
It kind of fits this broader trend towards more human-centric approaches we hear about, in areas like advanced manufacturing, Industry 5.0 stuff.
Exactly. The shift is towards a partnership where the capabilities of both are combined to achieve something neither could really do alone, especially when it comes to safety.
Okay.
And the sources make it very clear why this integration is so essential. While AI can absolutely boost performance and safety in many ways,
Yeah.
it has significant, well-documented limitations.
What kind of limitations are we talking about? Especially the ones that are most concerning when safety is on the line.
Well, think about things like transparency, often called the black box problem.
Right.
Understanding why an AI made a particular decision, especially a critical one, can be incredibly difficult, sometimes impossible.
Hmm.
AI can also be vulnerable to unexpected inputs or even, deliberate attacks. And a big one is its struggle with true uncertainty or edge cases.
Edge cases.
Yeah, those rare unforeseen situations in the real world that just fall outside its training data, like a garbage truck stopping unexpectedly in the middle of the road might be a perfect example for a self-driving system.
Yeah, the weird stuff that life throws at you. Things that are perfectly normal for a human driver to handle, but maybe, yeah, not for an AI that hasn't seen exactly that before.
Exactly. Humans, on the other hand, bring unique cognitive skills that current AI simply, well, lacks. Like things like high-level pattern discrimination, deeply understanding complex conceptual situations, and crucially, identifying potential hazards, even in novel or ambiguous scenarios.
I see.
By integrating humans, you're essentially using human intuition and adaptability to cover the AI's blind spots and its inherent weaknesses.
That makes a lot of sense. But integrating two complex, sometimes unpredictable entities, humans and machines especially,
Hmm.
where safety is non-negotiable, that sounds incredibly challenging from a system design perspective.
Oh, it absolutely is. And safety truly is the absolute priority in these industries. Adopting this human-machine collaboration introduces several significant hurdles.
Hmm.
The sheer complexity of integrating the roles, the responsibilities, the constant feedback loops between humans and machines, That's a major challenge right there.
Okay.
Then you have the safety issues tied directly to those AI limitations we just mentioned, lack of transparency, vulnerability, how they handle uncertainty.
And then you add human uncertainty into the mix. I mean, we're not perfectly predictable either.
Absolutely not. Humans have biases. They get fatigued, distracted. Our behavior isn't always deterministic in the way a machine's code might be, right?
Yeah.
So this combined challenge, the sort of probabilistic nature of AI outputs, and the inherent variability and uncertainty of human behavior makes crucial processes like regulatory certification incredibly difficult.
How so?
Well, how do you certify a system under stringent regulations like, say, the EU AI Act or the machinery regulation, when fundamental parts of that system are inherently unpredictable or opaque?
Wow. Yeah, I can see how that becomes a huge regulatory roadblock.
It is. And beyond the technical and human factors, there are also practical hurdles. Many industries still have relatively low levels of digitization.
Sure.
And there's often a general lack of deep AI expertise, which is a particular challenge for smaller companies wanting to adopt these systems. And of course, cybersecurity and privacy concerns are paramount, especially as these systems collect and process sensitive data about human workers or operators.
So safety isn't just about preventing a single collision or malfunction. It's really about the reliability and robustness of the entire integrated system.
Precisely. Safety is viewed as an emergent property of the system,
Emergent property, meaning.
meaning safety doesn't just reside in the human or the AI individually. It sort of emerges from the complex interactions and relationships between all the components, human and machine, within the system.
Okay.
And this demands that risk assessment isn't generic. It has to be highly specific to the domain and meticulously consider the precise role and potential failure modes of each part, human and AI, within that integrated system.
Okay, that lays out the landscape and the challenges pretty clearly. Let's pivot now to how AI actively helps humans in these systems. The sources dive into specific tasks where AI takes on like a supporting role to boost safety and efficiency.
Yes, exactly. AI is designed to assist humans by handling specific, well-defined tasks. This frees up human capacity and potentially enhances overall system safety. The research often categorizes these AI problems or tasks within CI into areas like planning, perception, communication, and control. Let's look at some concrete examples highlighted in the sources.
Like what? What specific jobs is AI doing to help out?
Okay, so in collaborative robotics, for instance, AI is heavily involved in robot control programming.
Right.
This is for robotic manipulators, often called cobots,
Cobots.
which are
Uh-huh.
specifically designed to work directly alongside humans in a shared space. Safety solutions here are absolutely crucial. Things like automatic collision avoidance, the robot stopping or moving away if a human gets too close,
Okay.
or adapting the robot's path and speed in real time based on human presence and actions.
So the robot isn't just blindly following a pre-programmed path, it's actually aware of the human and adjusting on the fly.
Exactly that. And to do this safely, researchers use techniques like ANN's artificial neural networks, which help the robot learn complex movements from data, and also embodied intelligence, which involves systems that understand and act based on their physical interaction with the environment. Think of a robot sort of feeling or sensing its surroundings.
Interesting.
They also use things like fuzzy control, which uses logic based on degrees of truth rather than strict true-false. That makes it good for handling uncertain inputs like, say, human gestures or how close someone is.
Ah, okay.
And this is vital for things like impedance control, where the robot reacts to physical contact in a way that feels safe and responsive to a human, like, yielding smoothly if you push it gently.
Wow. So the AI is enabling the robot to be a much more aware, physically responsive partner. What else does AI perceive?
Well, a fundamental task is human object detection and tracking. AI uses sensors, like cameras mostly, to identify and continuously track the location and movement of humans and other objects in the workspace.
Okay.
This information is then fed into safety monitoring systems to ensure separation or, predict potential conflicts before they happen.
And predicting what the human is about to do seems incredibly important for real collaboration.
Oh, absolutely. It's a frequently studied and, frankly, challenging area: human intention prediction and motion recognition. AI aims to predict what a human operator intends to do next, whether it's interpreting a gesture, recognizing a specific action sequence, or maybe anticipating a maneuver a driver is about to make.
Right.
This prediction helps the AI anticipate and cooperate more effectively and safely. Context is really key here. The AI might need to know if a human is reaching for a specific tool to understand their intent, for example.
Makes sense.
And combining different data sources like vision and maybe tactile input significantly improves the accuracy of these predictions for safety monitoring.
Okay.
It's important to note, though, that researchers often use probabilistic methods here because, well, human behavior isn't 100% certain, right?
Definitely not.
So the AI might calculate, say, an 80% probability the human will turn left. But achieving robustness and generalizing these predictions accurately across different people who all behave slightly differently, that remains a significant challenge.
So it's trying to guess what you'll do, but with a level of confidence baked in. That seems useful for managing the uncertainty. What about understanding the human's internal state, like how they're feeling or doing?
Yeah, that's another area. AI can also tackle human state recognition.
Okay.
This involves identifying a human operator's physical state, like their effort level, or
Uh-huh.
critically, their mental, cognitive, or affective state. Are they drowsy, distracted, overloaded, maybe stressed?
Wow.
Identifying states like drowsiness, attention levels, workload, or emotion allows the system to adapt its behavior in real time. And this could potentially prevent critical situations caused by human fatigue, distraction, or stress.
That could be huge.
Some studies report quite high accuracy rates for detecting these states, actually showing real promise for developing these human state-aware adaptive systems.
It's like the system is developing a richer understanding of its human partner's condition, almost like empathy, but algorithmic.
Something like that, yeah. And finally, AI's predictive power is leveraged in accident error prediction.
Predicting problems before they happen.
Exactly. AI can analyze data patterns to anticipate potential human-related critical situations, or even accidents before they occur. Examples from the sources include using Bayesian networks, that's a way of reasoning with probabilities and dependencies, to predict risk factors in complex systems like maritime navigation.
Okay.
Or using reinforcement learning, where a system learns by trial and error, getting rewards for good behavior,
Uh-huh.
to build adaptive forward collision warning systems in vehicles that consider the driver's context and behavior. Deep learning is also used to detect early precursors to operator errors in industrial settings. The overarching goal here is always proactive safety intervention, prevent the problem.
That's a pretty comprehensive suite of ways AI can support humans by perceiving, predicting, adapting. But you mentioned earlier it's a two-way street. How do humans assist AI, especially in making these systems safe?
Yes, that flip in perspective is absolutely crucial. Humans are vital inputs to AI systems, particularly for learning and for handling that persistent issue of uncertainty.
Mm.
This brings us to the concept of human-in-the-loop learning.
Human in the loop,
Right.
where the human is an active participant in the AI's learning process, not just like a user clicking buttons.
Exactly. This approach is especially needed when you have sparse or insufficient training data, or when you need to incorporate nuanced expert knowledge that's really hard for the AI to simply infer from raw data.
Okay.
Humans can be involved at various stages, maybe helping process data, actively supervising or providing feedback during model training, or even influencing the system's design and application. There are different dynamics, too, like active learning, where the AI actually prompts the human for input when it's uncertain, or machine teaching, where a human expert directly guides the AI's learning process.
And why is this direct human involvement so critical specifically for safety? What does the human bring?
Because humans provide the essential knowledge, the demonstrations, the supervision, and the corrective feedback that help the AI learn safely. And crucially, they help it detect anomalies or dangerous situations that the AI might entirely miss on its own.
Right.
Given the AI's limitations, like the black box nature or its potential vulnerability to unexpected inputs, the human's unique skills in pattern discrimination and hazard identification can directly help the system avoid or mitigate safety risks during its development and its operation.
Can you give a specific example of this human-in-the-loop learning approach in action?
Sure. Learning from demonstrations, LFD, is a really promising method highlighted in the sources, particularly applicable to training robots,
Okay.
LFD.
The idea is pretty simple. A robot learns a complex task like manipulating objects or navigating an environment by simply observing and imitating a human expert performing that task. So like watching and learning?
Exactly. It's quite intuitive and versatile.
Hmm.
However, current LFD techniques do have limitations. They often assume the human's demonstrations are always perfect or optimal.
Which they might not be.
Right. And they rely heavily on the quality and completeness of that human data.
So researchers are actively trying to make LFD more robust, I imagine.
Absolutely. Research efforts are focused on things like quantifying the human factors involved to understand and potentially improve demonstration quality, optimizing the learning algorithms to minimize the amount of time and effort required from the human expert, because expert time is valuable,
True.
and enabling the system to generalize the learned task to novel situations. And
True.
critically, teaching the system to recognize when it doesn't know what to do and needs to ask the human for help.
That seems vital, knowing when to ask for help.
It is. And future work specifically needs to focus on assessing the quality of the human feedback provided and detecting potential human errors or unusual inputs during the learning phase itself, because, let's face it, humans can make mistakes too.
That's a really vital point. The human isn't just a perfect source of data. They're another part of the system with their own potential for error.
Yeah.
It makes total sense that the AI needs to learn from and adapt to human variability as well. Okay, let's zoom in on automated driving now, as it seems like a perfect real-world example where all these concepts, human AI, collaboration, safety challenges, really converge.
Automated driving systems, or ADS, are indeed a prime case study for collaborative intelligence. The sources point out significant shift happening,
Oh, yeah.
moving away from the older idea of simple takeover scenarios, where the human is essentially a passive passenger until the system suddenly throws control back at them.
Right, the panic moment.
Exactly. Moving away from that towards what's being called cooperative driving.
Cooperative driving, which sounds much more like the dynamic partnership we've been discussing all along.
Precisely. Cooperative driving envisions a much more collaborative partnership, where the human driver isn't just a disconnected backup, but an integral, active part of the system, involved in decision-making alongside the automation.
Okay.
And research findings highlight several benefits to this approach. Things like higher driver enjoyment, greater ease of use, increased trust in the system, reduced mental load, and even an enhanced sense of autonomy for the human driver. They actually feel more in control of the overall journey, paradoxically.
That's interesting. So it's not just about technical performance or safety metrics, but also improving the actual human experience of using the system.
Right, and one source proposes a helpful framework for designing this kind of human-vehicle cooperation, highlighting 3 key aspects.
Okay, what are they?
First, there's the cooperation use case. This is about clearly defining the specific scenario. Who are the agents involved? Is it just the driver and automation, or maybe a remote teleoperator's involved?
Right.
What's the motivation for initiating cooperation? Is the driver requesting control because they want to, or is the system asking because it detects a hazard? And importantly, how critical or urgent is the scenario?
Got it. It's like setting the stage and understanding the context for the interaction first.
Yes. Second, the cooperation frame. This describes how the cooperation strategy actually unfolds.
Okay.
It considers the relationship dynamics between the agents. Is the control relationship strictly deterministic, like AI always has priority, or is there a process of dynamic negotiation? And importantly, how are tasks shared? This involves looking at the different hierarchies of driving tasks, from high-level strategic planning, like choosing a route, down to tactical maneuvers like overtaking, and then operational control like steering and braking. And it also looks at the steps within the basic driving task loop: perception, interpretation, planning, execution, and evaluation.
Right, the whole cycle.
For instance, sharing tasks at the perception stage, where maybe the human points something out to the AI, is generally easier and safer in low criticality situations where you have more time to communicate.
Okay, so the when and how of sharing the actual job of driving, depending on the situation.
Exactly. And finally, the third piece is the human-machine interface, HMI.
The dashboard, the sounds, all that.
Yeah, basically how the interaction is actually implemented. The input and output modalities use visual displays, auditory alerts, haptic feedback through the steering wheel or seat, stuff like that.
Okay.
And crucially, it's also about the mental models this interface helps the user build. Does the interface clearly communicate what the system is doing, what it's capable of, what its intentions are?
So does the human understand what's going on?
Precisely. A good HMI helps the human build an accurate mental model of the system, which is absolutely vital for trust and effective collaboration.
That framework provides a really structured way to think about designing this complex interaction. And the sources also identify some key human factors that are essential for successful cooperation in driving, beyond just the interface itself.
Yeah, they highlight 4 critical human factors. Mutual predictability.
Okay.
Can the human and the AI reliably anticipate what the other will do? Directability. can the human easily influence or direct the AI's actions when needed?
Makes sense.
Shared situation representation. Do both the human and the AI understand the driving environment and the current situation in a similar way?
Mm.
And finally, trust and calibrated reliance. Does the human trust the system appropriately, neither too much nor too little, and rely on it in a way that actually matches its real capabilities?
That calibrated reliance seems particularly important. Not blind faith, but informed trust based on evidence.
Absolutely. And this brings us nicely to a deeper look at the human side of this partnership, particularly the psychological aspects of working with AI in these uncertain situations.
Okay, let's talk about that. How humans navigate uncertainty when collaborating with AI, and what that means for maintaining control and ultimately safety.
Right. So when humans work jointly with AI on tasks that involve significant uncertainty, which, let's be honest, is common in the real world, they often learn how to do this effectively through a process of exploration and exploitation over time.
Exploration and exploitation, like trial and error.
Sort of, yeah. You're trying different ways of interacting, exploring the possibilities, and then you start relying on the strategies that seem to work best, exploiting that knowledge.
Okay. And the sources mention a concept called uncertainty tolerance that plays a big role here.
Yes, uncertainty tolerance is identified as a major psychological factor influencing how humans interact with these systems. It basically describes an individual's general comfort level with ambiguity and unpredictability.
So some people are just more okay with not knowing exactly what's going to happen.
Exactly. If you have low uncertainty tolerance, you might be more hesitant to use automation, maybe feel compelled to constantly monitor it very closely.
Right.
If you have high tolerance, you might be more willing to explore the AI's capabilities and delegate tasks more readily, perhaps even too readily sometimes.
And humans learn from both their own errors and the AI's errors in this whole process.
Crucially, yes.
Yeah.
Understanding how errors occur, who made them, was it the human or the AI, and what their consequences were, is vital for learning and adapting the joint performance of the human-AI team.
Hmm.
The sources use examples from Tesla's automated driving systems to illustrate this point. For instance, an AI might encounter an edge case, like that garbage truck stopping unexpectedly in the road that we talked about earlier,
Yeah.
which is a normal occurrence for a human driver, but might be confusing or unpredictable for the AI.
And how does that create uncertainty for the human driver in that moment?
Well, in one example from the forces, the AI, trying to maintain efficiency, attempted a pretty unconventional solution.
Hmm.
It started turning into someone's driveway to get around the truck. Yeah. This decision, while maybe efficient from a simple routing perspective, generated significant uncertainty and anxiety for the human driver because it was completely unexpected and felt unsafe.
I bet.
So the human immediately intervened. It really highlights a potential conflict between the AI's operational goals, like efficiency, and the human's fundamental goal, which is safety.
That's a really clear illustration of the AI's behavior creating uncertainty for the human. What about the flip side, the danger of the human not being engaged enough?
Yeah, accident reports, also discussed in the sources, tragically illustrate the dangers of the human driver not being sufficiently active in monitoring and correcting AI errors.
Hmm.
This was particularly evident in some earlier systems where the design might not have adequately supported a constant feedback loop for human intervention. When the human becomes disengaged and stops monitoring, well, AI errors can go unnoticed until it's far too late to react.
This sounds like the risk associated with having too high uncertainty tolerance, or maybe just misplaced trust in the system's capabilities.
Exactly. High uncertainty tolerance can contribute to overconfidence in the AI and lead straight to automation complacency.
Automation complacency.
Yeah, it's a state where the human becomes disengaged, their attention drifts, they lose crucial situation awareness. It's the risk of essentially falling asleep at the wheel mentally,
Right.
which is incredibly dangerous when the human is still functionally part of the safety system and needed to monitor and potentially intervene quickly.
So the key then is to remain an active participant, constantly monitoring and dynamically assessing who the human or the AI is best suited to handle a specific task or situation at any given moment.
It's not static.
Precisely. The relationship isn't static at all. It's a dynamic partnership that requires constant adaptation and appropriate allocation of tasks based on the relative strengths and current states of both the human and the AI in that specific context.
This naturally brings up significant questions about control and, crucially, responsibility. If an automated system makes a critical error, who's accountable? Who's responsible? This is a core ethical and practical challenge, and it's addressed by the concept of meaningful human control, MHC, over automated driving systems, which is discussed in one of the sources.
Okay, meaningful human control.
The aim of MHC is fundamentally to protect safety and prevent the emergence of responsibility gaps.
Responsibility gaps, which is that really concerning situation where something goes wrong, but it's genuinely unclear who is supposed to prevent it or who should be held accountable legally or morally.
Exactly that. The core assumption underlying MHC, as presented in the research, is that humans and institutions should remain ultimately in control and morally responsible, even if that control isn't always direct, hands-on control in every single moment.
Okay.
The system needs to be designed in a way that ensures this is possible.
And the sources break down MHC into two conditions necessary for it to actually exist.
Yes. The first is tracking. The system's behavior should align with the relevant reasons and intentions of the relevant human actors involved.
That sounds complex.
It is quite complex to achieve in practice, ensuring the AI truly understands and acts on human values or goals.
Yeah.
The second condition, and often considered more actionable from a system design and regulatory perspective, is tracing.
Tracing.
Yeah, any potentially dangerous event that occurs must be traceable back to a specific human actor, whether that's the driver, the system designer, the regulator, the manufacturer, someone.
I see.
This traceability is absolutely crucial for ensuring accountability and preventing those responsibility gaps.
So if an accident happens, you need to be able to follow a clear line back, like breadcrumbs, to a human decision or action or maybe inaction that contributed to it.
Precisely. The potential for responsibility gaps is a very real concern, situations where an undesirable outcome occurs. But because of the system's complexity or opacity, it's genuinely unclear who is supposed to prevent it or who bears moral or legal responsibility.
Yeah.
The concept of the moral crumple zone is sometimes used here.
The moral crumple zone.
Yeah, like a car's physical crumple zone is designed to absorb impact in a crash. The system might inadvertently be designed in such a way that the human driver ends up absorbing the blame for something they genuinely couldn't control or prevent due to the automation's behavior or failure.
Oof. That sounds like a very vulnerable position for the human to be put in.
It is.
Yeah.
Automation doesn't eliminate the human's role. It fundamentally shifts it. Drivers aren't just manually controlling the vehicle anymore. They have these new, demanding monitoring duties that, frankly, humans are not naturally good at maintaining for extended periods.
Right. Sustained vigilance is hard.
Exactly. This can lead into what's sometimes called the unsafe valley of automation, a state where the human is neither fully engaged in manual control nor fully disengaged, but is stuck in this complex, cognitively demanding state of passive monitoring, potentially losing critical skills and situation awareness. Now, requiring alignment between driver capabilities and system design aims to help humans navigate out of that unsafe valley. And the sources also briefly mention that initial research suggests individual personality traits might actually play a role in how drivers interact with and trust automation.
Really?
Yeah, hinting that future designs might need to consider individual differences more carefully.
Which adds yet another layer of complexity to designing these systems safely and effectively.
Definitely. Realizing these concepts of MHC, tracking, and especially tracing effectively requires incredibly careful system design, extensive real-world testing and feedback, and really clear communication among all stakeholders, designers, regulators, manufacturers, and of course the users.
So pulling all this together then, where does this leave us? What's the path forward for this continuously evolving partnership between humans and AI, especially in these safety critical areas?
Well, I think we've seen that collaborative intelligence is really vital for achieving safety in high-stakes areas. It does this by combining the computational strengths of AI, like performance, data analysis, predictive power, with those unique human strengths of perception, complex judgment, handling novel uncertainty.
Safety is absolutely paramount, but it's also incredibly complex. It requires not just advanced technology, but careful integration of human and machine roles, rigorous evaluation, and appropriate regulation. Humans aren't passive users in this. They are active, learning participants, constantly adapting how they work with these systems and calibrating their trust and tolerance for uncertainty.
Yeah.
And ensuring meaningful human control and clear lines of responsibility. Well, those are fundamental ethical and practical requirements for accountability.
What are the big challenges that researchers are still grappling with in making this collaboration work safely and effectively moving forward?
The sources point to several ongoing challenges. Things like developing AI systems that are more dynamically adaptive and, importantly, more explainable. Improving how these systems learn effectively and safely from human input.
and how they manage or signal errors and uncertainty.
There's also a clear need for better training programs for humans who will be working alongside AI. Navigating the complex and evolving regulatory landscapes across different industries is another big one, and just continuing to refine the mechanisms for tracing responsibility when things inevitably go wrong in complex systems.
It definitely sounds like this isn't a finished product by any means, but more like a continuous journey of learning and adaptation for both the humans and the AIs involved.
Absolutely. The automation augmentation frontier, as one source nicely puts it, is continuously expanding. The future of safety-critical systems involves a dynamic, ongoing learning process where humans and AI adapt and improve together, guided always by the fundamental principles of safety, effective collaboration, and clear accountability.
So, to sum up this deep dive then, we've journeyed through the fascinating and really critical world of collaborative intelligence. We've seen that integrating humans and AI isn't just a design choice. It's pretty much the essential path for ensuring safety in critical industries. We explored the specific ways AI helps humans with tasks like prediction and perception, how humans are vital in helping AI learn safely and manage uncertainty through methods like human in the loop and learning from demonstrations, and why establishing clear control and traceability for responsibility is absolutely paramount, using automated driving as a key illustrative example throughout.
Yeah, it powerfully reinforces the core message.
Yeah.
This isn't some zero-sum game of humans versus machines competing for tasks. It's really about building a sophisticated, dynamic partnership.
Right.
It's a constantly evolving relationship where both sides need to learn, adapt, and build trust. But, and this is key, that trust must be calibrated, earned through predictable and safe behavior, and constantly monitored by the human.
Which leaves us with a final thought to maybe ponder as we wrap up. As AI systems become increasingly capable and our interactions with them become deeper and more integrated into critical, safety-sensitive tasks, who is truly in the driver's seat when something unexpected happens or inevitably when something goes wrong?
A big question.
Yeah. How do we design and regulate these complex systems to ensure they truly empower and protect us, enhancing our capabilities and safety, rather than simply automating critical decisions away and potentially leaving us exposed in that unsafe valley we talked about? The conversation around responsibility and meaningful human control in the age of AI, well, it's far from settled.